5.4, integrals, antiderivatives of exponents. Well, let's review in our brain here the derivatives of exponents. Let's do that first, and then we'll be able to go backwards, hopefully. Do you remember what the derivative of e to the orange triangle is? In some ways, it's the easiest derivative there is.
Oh, it's just times the triangle. Sorry.
It's just
times the triangle.
Wait, what times the triangle?
E to the triangle times the triangle.
E to the triangle times not the triangle, but the derivative of the triangle, the chain rule.
This is the only thing I remember.
So here, you try these real quick. This will be warm-ups instead. Try those two. So today is backwards day. Right? The better you drive forward, the easier it is to drive backwards. But even if you're really good driving forwards, it's kind of tricky driving backwards. So the antiderivative of e to the u, du, any guesses? The derivative of e to the x is e to the x. So the antiderivative of e to the x is e to the x. Just don't forget the plus c. So that's the big news for today. But if you know the forward rule, that's not really like big news. It's like, oh yeah, we kind of know this one. This is our favorite one because e to the x, especially if f of x, if there's no chain rule involved. Like, what's the 547th derivative of e to the x? Let's back up. What's the first derivative of e to the x? And the second derivative is e to the x. And the third derivative is e to the x. So the 547th derivative is e to the x. That only works when there's not a chain rule. Or I guess I should say when the chain rule is 1. If it was anything else, then this would get a little bit trickier. Let's do an example. Antiderivative of e to the 5x dx. Well, I guess what's making this problem more complicated than we'd like it to be? The 5, yep. So what's our trick for making complicated integrals a little bit easier to work with? U substitution. So if we don't like the 5x, we can replace the 5x with u. So I need a 5 and a 1/5. So 1/5 antiderivative of e to the u du. And I don't want to say that's going to be all of the problems today, but most of them are going to get down to integral of e to the u du. So it'll be about figuring out the u substitution to make that work. So the antiderivative of e to the u is e to the u. And that would be an easy one to check because the chain rule would give us a 5, and the 5 and the 1/5 would cancel each other out, and we'd just be back to e to the 5x. Some of you may get to the point where on ones like this, you don't show the u substitution, you kind of just handle it because it's only a constant. antiderivative, integrate 4 e to the 1 minus x dx. Happy Monday morning, Emma. What do you think a good idea for u would be, especially if we want e to the u to show up? U substitution is a little bit easier for this because I really want e to the u to show up. So what should u be, Emma? 1 minus x would give me e to the u. So let's try that and hope that it works. du. Izzy, what's du then? -1. Or -1 dx, would be technically correct. So that's not too bad. I can make a -1 be there, as long as I put it on the outside as well. So I'm getting closer. Sarah, there's a 4 that's sort of in the way here, messing things up. What can I do with the 4? Yeah, just move him out front. So out front there's now a -4. Antiderivative of e to the u du. Natalie, what's the antiderivative of e to the u? Yeah, you're kind of filling in on the fly there. It's e to the u. There's still a -4 out front and a plus c. You guys skipping steps on me, which is fine. So again, a whole lot of u substitution, but I think u substitution is a little easier today because it's almost always the exponent of e, so that e to the u shows up. Good question. Because that 4 wasn't part of my u du stuff. That 4 was just a constant that I didn't like, so I just moved him out front. I didn't multiply. I didn't add the 4 and a 1/4. I just moved the 4 out of the way. Number 3. Antiderivative of sine of x times e to the cosine x dx. Running out of popsicle sticks. If you haven't been called, your time's coming. Mark, thoughts on what u should be? Cosine. I like that pick. And the reason I like that pick, Dia, is because what's du?
Sine.
Which one? What? I like sine. Is it positive or negative? Derivative of sine is cosine. Derivative of cosine is negative sine. So, this isn't perfect. I need a negative sign on there, which means I'll mean a negative out front. Counter that. So I have negative integral e to the u du. Again, they almost all turn out that way today. It's just about the steps before that. Tierney, what's the antiderivative of e to the u? E to the u. So negative e to the cosine x plus c. By the way, all of these are relatively easy to check. We haven't done it, but to take a derivative of e to the cosine x, you know it would be e to the cosine of x times the derivative of cosine of x, and so you can see how it would work. Well, if you thought those were pretty straightforward, you're right. And then part of you are probably thinking, well, is there more to it? Of course there's more to it. algebra. Let's do some algebra first on this one. So what's e to the 4x divided by e to the x? Algebra with someone's holding up the 3 because there's food in your mouth. But yes, you are correct. Healthy food in your mouth. E to the 3x plus, what's 2e to the 2x divided by e to the x? 2e to the x. And then I don't want to write 1 over e to the x, I want e to the negative x. And be careful, I still haven't integrated that yet. Some people, they'll do the algebra and then celebrate like they, well, I mean, yeah, you did the algebra right, but you still haven't integrated this. All right, in some ways that's 3 separate u substitution problems, but they're easy u substitution problems, so maybe I can get by without like writing out the u substitution. What do we think the antiderivative of e to the 3x is going to be? I mean, it's got to be e to the 3x, but now if I'm thinking backwards, if I take the derivative of e to the 3x, yeah, I'm off by a 3, so I need a 1/3. That's sort of u substitution on the fly for simple ones, simpler ones anyway. Yeah, some of you are looking at me like you don't like that. If you don't like that, then you would say u is 3x, du is 3 dx, and so you do the 3 and the 1/3. How about the next one? The next one doesn't require any u substitution. Just kind of have to ignore the 2 and then put it back on at the end. The antiderivative of e to the x is e to the x, and the 2 is just going along for the ride there. What about that last one? What would u be? If we wanted to write it out, what would u be? Negative x. So some of you can see that and make the fix sort of on the fly. Others of you would be like, let's write it out and then play it safe. So I would need a negative on the dx, which means a negative out front. So minus e to the negative x plus c. So I guess 2 points of doing that example. You needed to do algebra first. You can't antiderivative at the top and antiderivative at the bottom and put them together. It doesn't work. So you had to do algebra first. And then the second part of that example was, for relatively easy ones, some of you are going to start doing minor u substitution basically in your head. Like, this is almost there, it's off by a 1/3, let me just fix it. If that bothers you, write it out. Perfectly okay. Antiderivative, natural log, e to the 2x minus 1. That looks complicated. But there's an algebra power or an algebra property going on here. Do you know what natural log of e to the x is? Back up one more. Do you know what I can do with that x? Property of logs. Right, the natural log of 5 to the 4th, you can put the 4 down front. You can put the x down front. So again, not calculus, but algebra, I can take that 2x minus 1, move it to the front. Do you remember what the natural log of e is? would be helpful and make this problem a lot easier. Natural log of e. It's 1.
Yeah.
So
It always is.
there's no natural logs or e's in this problem once we do some algebra. So x squared minus x plus c. Let's do one more. I'm skipping one. The one I'm skipping is let me just show you. Sort of see it. So what's different about that problem? It has limits. So you'll let u be the top, du is basically that, and then you'll have to fix the limits when you integrate. Or put the u stuff, put the x stuff back in and use the original limits. You guys were okay on that test. That problems 5 and 6 with the u substitution. Some of you switched it back to x stuff and used the original limits, which is fine. Some of you left it as u and used the u limits, which is what I did here. But a few of you did this, but then you put 0 and square root of 2 back, but those are x things rather than u things. So again, be careful with u's and x's. If you switch it to u's, great, but switch everybody to u's. If you want to switch it back to x's and use the original limits, because those are x limits, that's fine too, but like go all in with the u's or all in with the x's. There was quite a few people who got jumbled up on that. All right, last one. Find the particular solution. There was one of these on the test. F double prime of x equals sine of x plus e to the 2x. F prime of 0 is 1/2, and f of 0 is 1/4. So what do I do? I guess I should say find the particular solution for f of x. So I need to find f. I have f double prime. So what do I need to do? How do I get from f double prime back towards f anyway? Twice, yes. Do what twice? Integral or antiderivative. So the antiderivative, so f prime will be the antiderivative of sine of x plus e to the 2x. And maybe you'd show that step, maybe you would just do the antiderivative and not show the step. Let's see. Antiderivative of sine of x. Emily? Antiderivative of sine.
It's cosine of x.
What's the derivative of cosine? Remember this going forward, going backward stuff. The derivative of sine is cosine. And the derivative of cosine is negative sine. So that means the antiderivative of sine is negative cosine. Andrew, for that second part, e to the 2x, do you want to do a u substitution, or can you handle that one on the fly? Possibly on the fly. So what do you think the answer is? Probably some sort of 1/2 in there, and that would be right. Again, if you don't like that, then you go u equals 2x, du equals 2, and there's where the 2 and the 1/2 come from. What have I left off of my answer here? plus c, especially when I'm looking over here. There's nothing to solve for until the plus c shows up. So f prime of 0 is 1/2. So 1/2 equals negative cosine of 0 plus 1/2 e to the 0 plus c. What's cosine of 0? 1. What's e to the 0? 1. So let's see, does all this cancel out? No, it doesn't cancel all cancel out. 1/2 equals negative 1/2 plus c. So if I move the 1/2 over, that first c is 1. Here's where quite a few people made a mistake on the test. Is they got that, and then when they integrated again, they forgot to include that 1 as part of f prime that needs to be integrated. Well, same thing. Let's integrate one more time to get back to f. I'm out of popsicle sticks, and I'm almost out of time. What's the antiderivative of negative cosine? Or maybe we should just ignore the negative. What's the antiderivative of cosine? Sine. So negative sine of x. Oh, I should call on Andrew again because he got this one right the first time. The antiderivative of e to the 2x is half. So what's the antiderivative of 1/2 e to the 2x going to be? Probably 1/4. And then plus x plus c. And then our last piece of information, f of 0 is 1/4. Again, that's a separate c, so if you want to call it c2, that's fine. Oh, what's c2 going to equal? This works out quite well. Sine of 0 is 0. E to the 0 is 1. So 1/4 equals 1/4 plus c2. So c2 is 0. But I need to write my final answer here. Negative sine of x plus 1/4 e to the 2x plus 1, or no, plus x plus 0. Alright, we've done that kind of problem on each of the last two tests, so you're going to continue to see that. We just make it different by putting in different pieces to start with. Alright, this is section 5.4 for those fighting with CalcChat at home. Page 354. 91 to 117 odd. I'm going to omit a bunch here in a minute. 123, 125. But omit 99, 103, 107, 115. Maybe it would have been easier to just write out the ones that you do need to do. Right. Again, keep up. I know it's hard, but it only gets harder when you're not even trying. So give those a go. Check with CalcChat or come with questions tomorrow. But don't let this stuff start piling up on you.